Water use in poultry processing plants. I never talk about commercial processing without giving ourselves some perspective to everybody in the room, order of magnitude. I try to keep these pie charts upgraded all the time, or updated. This is USDA NISS information just from this year, looking at last year commercial processing in the U.S. People always ask me, why do we talk about broiler meat all the time? Well, this is why we talk about broiler meat in the U.S. Because when I talk about what USDA calls young chickens, what we call broilers, you can see the dominance. Whether we look at we're almost approaching 10 billion at this point, if you want to notice that number, but 96% is devoted to chicken meat, young chickens or broilers. And then if we include weight into that, turkeys take that bigger slice, but still, right, broilers account for almost 90% by weight. That's where our industry is today. When we talk about water use, this is a kind of a figure I developed a number of years ago to try to explain the continuum through the years of where we are with water use. I start this thing back in 1972. That's with the EPA. And their Clean Water Act in 1972. Prior to that, water wasn't a big thing on the radar, but it certainly did come onto the radar in the early 1970s. I always put a question mark here because I always say, because it wasn't a focus area, we really don't know how much water was being used out there. But I answered that question recently. For another talk I was giving, looking at wastewater, that's a big part of my job, looking at treating of the wastewater our processing plants produce. I found this paper. This is from 1977. The new concept they're talking about, I know you're not necessarily wastewater folks, they're talking about dissolved air flotation, DAF technology, which all of our plants use as part of their wastewater treatment processes. But in this paper in 77, at the very beginning of it, and I've highlighted it here, they say, for example, a typical plant will process 125,000 birds per day and discharge over 2 million gallons per day. And it's a math problem then, and I did it. Well, there it is. So even as 1977, they were reporting that plants were utilizing over 16 gallons per bird processed, okay? From that sort of milestone or place in time, we started to see over the next 20 years or so, a couple decades, a real push, all these different industry water conservation practices. And you see it get driven down way below the 6 gallon mark, down below 5 even, as an average across the industry. That was up until the mid-1990s and 1996. You can look at your neighbor. This is the interactive portion of the talk. Look at your neighbor and say, what affected, if you could, fill in the blank here, what happened in the mid-1990s that caused water use to really reverse direction? I'll give you 3 or 4 seconds. I don't have much time here. Thank you so much. It is HACCP. So in the mid-1990s, HACCP comes along on the food safety side. Hazard analysis, critical control point, that comes into the plants, and the answer for so many of our processing plants was water. Put water to it. Wash equipments and birds again and again and again. We can see the impact of that directly from a study done when Julie Northcutt, Deanna Jones were both still together at the USDA ARS in Athens. They did a couple landmark sort of surveys in the early 2000s. And this paper, I'll draw a quote from that. Here it is. Overall, the average water use prior to the implementation of HACCP was about 5.5 gallons, 20.6 liters, right? And currently, that had moved up to in the early 2000s to 26 liters per bird. Put the math on that. That's a 27% increase. So a third we saw jump in just a very short period of time. So the question always comes up, how much water to begin with does the industry use? Just an order of magnitude. We did it with the number of birds by weight and by number, but how much water? So if I take what Julie and Deanna showed us in the early 2000s, if we use that number just as reference, 7 gallons per bird, we can run the numbers, right? So I'm using a kind of a range of 19 to 38 liters. We plug in our 9 billion broilers. Well, that's what we're talking about. We're talking about in the order of billions of gallons of high-strength wastewater produced, or billions of liters of high-strength wastewater produced that we've got to do something with. The other thing that comes in for our processors is cost, okay? How much does water cost? And I'm afraid I lost my my y-axis here when I transferred this. What you're looking at here is what we call typically in municipal water and sewer systems, dollars per thousand. So what we usually charge is water/sewer for 1,000 gallons of water. So 1,000 gallons goes through your water meter, and you can pay some dollar value based on that 1,000 gallons. And here we're using the poultry capital of the world, Gainesville, Georgia, and you see the increase in that over time from 1960 to 2008. But it's not 2008 anymore, is it? Well, it's not, so let's bring this up to date a little bit, because I did. In 2022, that is now moved over $16.60 per thousand. What does it mean in real life cost? Let's talk. I'm talking just the water bill that these plants receive. So if we take a typical plant doing 250,000 birds per day, that's 7 gallons per bird, over a 260-day processing year, what are we talking about? Over $7.5 million just in water. Doesn't include any sort of surcharges, won't go into that today, any sort of on-site wastewater treatment costs, none of that, just simply what comes in your bill. So now we know the total volume, we know about how much it costs. Where are we using water? That question goes up. You'll notice I brought back up this paper from 1977, Woodard et al., talking about their new concept in the treatment of waste with DAF. And actually in there, this is real hard to see, I apologize, but I'm just trying to make the point here that even back then, they were trying to make decisions or find out at least where water was being used in the process. So they did this in million gallons per day. It's kind of hard to see here, but at least they're attempting to try to figure out where water's happening. There's a lot of new or more modern looks at that. When I picked this paper, this is out of Amorim et al. Out of Brazil. This water conservation and effluent minimization looking at a poultry slaughterhouse. It reveals one of the problems or issues we have in this area. And the problem is, where do you put your buckets to decide where the water's being used? How do you divide up that puzzle? I'll show you an example. This is hard again to see. I know this is small, but this plant, number one here, this plant happens to have an ice plant. Some plants do, some plants don't. They include that. They also have, I don't know what number 5 down here is, washing of boxes. I don't know what boxes they're washing, but it says washing of boxes. But what they did here is they did the first graph. They isolate what we call productive processes into one large group, saying that accounts for 62% of their water use, and then they break that out again, okay? Now, this is a Brazilian plant, and this was interesting to me because you'll see, compared to what we kind of report in the United States, they put 50% of their processing water use into this bucket of scalding and defeathering. And you'll see comparatively how that changes with what we do. Further inspection, because this was 2007, I found this in 2021, Bologna, and their sustainable water management in slaughterhouses by Cleaner Production. This was a review. I said, ooh, this is going to be a good one. I found this graph, and I said, ooh, they give numbers too, but guess what? Look closely at that, and you're going to realize something. Guess where they took all their numbers? From the previous study I just told you. They just duplicated those and said this is where poultry processing plants use their water. There is a good chart in here, though, that actually talks about water use, right? And I'll highlight chicken, looking at, 5 studies here from Brazil, papers, and also one from the United Kingdom, looking a little bit here, giving you a comparison, if you will, of these plants across. But again, it's hard to match apples to apples when you're putting things in different buckets, right? I'll use this because it's self-serving. This is the manual that we use to teach poultry processing wastewater operators around the United States of America how to treat poultry processing wastewater. I do this course in conjunction with U.S. Poultry and Egg, and this is our new manual that we recently updated. And in there we have this chart. This is the chart that we utilize over lots of different data sources to kind of summarize where water is used through that production or the processing production in a processing plant. Hard to understand it in scales. I like pie, so here we go. So we do this in a pie chart. It's a lot easier to understand, okay? It jumps out at you at what stages those have. One of the problems, though, up until this point that I talked, we continue to see an issue with, and that is when we talk about slaughter plants, we have what I almost call an archaic unit of gallons per bird, right? And if you're in the business like I am, it gets me to thinking, I got a problem with gallon per bird. Why do I have a problem? Well, I'll point to, again, a self-serving document. This is an extension bulletin I did back in 2017, encouraging the industry to move from gallons per bird to some other sort of metric to understand how much water we're using. In this case, I called it gallons per thousand. What I did here, and this is also, I really am not pandering to our audience. I had no idea, Terrence, that you were going to be in here from Watt Poultry. This is actually, I developed this directly from Watt Poultry USA annually, and as a matter of fact, if you go out to their table out there, you've got the list of the 2024 plants and what they're processing and what they're. I used this back then in 2017 to do this document, do this extension bulletin. What I did is out of that list, I selected 85 plants from the Georgia, Arkansas, Alabama, Mississippi, and North Carolina. And the whole point here, guys, is poultry slaughter plants aren't just poultry slaughter plants. They do all sorts of other things inside those plants. Only one of those 85 plants, and I did this, what I did is develop this figure that shows just how many processing operations go on in what we call slaughter plants. Only one of those plants only slaughtered birds. We had one plant, or one or two plants that did 8 different processes. Meaning I take a whole carcass and then I do what with it, and then something else with it, and something else. Each one of those using water. Ultimately, what I did here is did a math situation, totally fictional, set it up so the results came out great. We do this scientists all the time. I nailed this, right? My 4 fictional plants, but the point I showed is what? If you graph that, right, if you did gallons per bird, it tells you one picture. But if you actually look at it at gallons per 1,000 pounds handled, it flips it completely over. The plant that looked the worst in gallons per bird was actually being the most efficient at using water. Why? Because they were doing 6, 7, 8 processing steps beyond what we call primary slaughter. I hope that makes sense to you. And it's starting to get in the industry. I picked AgriStats here. Boy, they're really easy to read their charts, right? But if you notice, Here's one that if you do AgriStats today, you'll see they've got water and sewer cost, and the unit is cents per bird, but you go a couple pages beyond that, and look what they have now. Water and sewer cost in cents per pound, okay? And all of a sudden it normalizes things. It makes a lot of more sense to make plants look right, much more efficient. Because of this whole situation, regardless if we look at it gallons per bird, gallons per 1,000, right? Ultimately, it's one of the things we're really big in is this world of water conservation. And how do we attack that? Well, we'll talk about it briefly. First, you got to define it. I think most people have some sort of definition, but there's some terms I think you need to understand more directly, even though they sound like they're repeating themselves. So water conservation is defined as that beneficial reduction of water use, water waste, and or water loss. Sounds kind of similar, but I do have to make this point. I constantly do this for the industry folks, my processing plants around the country. How many production systems, this can be anywhere, but how many production systems do you see this happening, right? We increase production without increasing the use of a utility. Is that conservation? Shake your head one way or the other. Yeah, it's conservation. We do a terrible job telling this story. That line of broiler production continues to climb year after year, and we see even if water use stays steady, that's water conservation. Increased production with the same use of water is also conservation. But we also see this, what is this water waste, water loss? Seems like we're repeating ourselves. So, man, I'm being very self-serving today. Look at that. Who wrote that chapter? That's me. Water conservation and processing facilities from about a decade ago. In this, I developed this figure to try to get people to understand, our industry folks, what's going on in our plants. So, total water use coming into the plant. I got two ways I can go. This is a hard line on purpose. I have the water that makes it somewhere that I want to use, and then I have this thing called water loss, our second audience participation moment. In just a second, I'm going to tell you to look at your neighbor and tell them what is the major source of water loss. This is water that never makes it. It comes through the water meter, but never makes it where we want to use it in the plant. What is the culprit? What is the thing that causes more water loss than anything in our poultry processing facilities? Talk to your neighbor. Awful quiet. Say, somebody yell it out. Yeah, leaks, right? It's all about leaks, and there's no way for me to, I got a whole talk on this, and we teach students. You can go to any search engine, put in water drip calculator, and there are these wonderful websites where you can go in and literally measure the drips coming from a leak, or measure a stream, plug it in, and it'll tell you, because most of these run what? Right, just when we're working? Heck no. They run 24 hours a day, 365 days a year. And these things will tell you on a daily basis, monthly basis, and yearly basis how much water you're wasting. That drip is actually thousands and thousands and thousands of gallons, which means what? Thousands and thousands of dollars, okay? Ultimately, once we get to our intended water use, hold the right button here, our intended water use, we can subdivide that. I make this purposely a dotted line. And this is where I call the difference between water waste, right, and efficient water use, okay? And what is water waste? Well, there's multiple examples. I don't have the time here today, so we'll talk about it, right? An example would be SOPs, just the way we operate our plants. What are examples of that? Well, this picture's representing using water as a broom. Why go do dry cleanup when I can hit it with high pressure hot water, move it all over the plant, and man, it makes it so easy for me. Or we have some regulation that says I've got to keep a surface with some water on it, and my maintenance manager is going to save a bunch of money, so he gets a piece of pipe and drills holes all through it, right? I walk in here and put one engineered nozzle here, use about 1/10 of the water, and generate the same sort of thing that I need. So that's that idea, okay? That's that idea. If we look ultimately at trying to do these water conservations, one of the things I want to highlight is those big pieces of pie, you'll notice are what? They're cumulative areas, aren't they? They're areas where a lot of stuff, sanitation here we mean is cleaning and sanitizing the plant. That's the whole facility. When we talk about evisceration, we're talking about machine after machine. So a lot of the concentration in water conservation has been in single locations. Always not for the reason we think, but I'll give you an example here, like scalding, okay? We'll pick scalding. The manufacturers, those line manufacturers, I'm playing to our next speaker here, Assembly. Don't worry, you're in here. Mario's in here. We got you, right? But that traditional scalder configuration does what? Well, we don't really think about this necessarily in the water scheme, but guess what? We drive so much. Anybody here been in a scalding area in a traditional poultry processing plant? If you're wearing glasses, the one thing you won't do is do that for very long because you can't see. There's so much moisture in the air, so hot, so humid and moisture driven that we've seen some, techniques done here. And I'm trying to be equal opportunity here. So here's an example, Bader, right? And their turbo scalder, what do? Well, they cover it up. Okay, well, that's not a bad step. How about we go another step? We'll go to mine. If I've seen this in action, their new Jetstream scalder. This is usually air agitated, Okay, what do? There's no air. They drive the water up, it flips and drives that water down. If you've ever seen these in action, it completely changes the atmosphere of scalding rooms. You can walk around, I can wear my glasses, it's not a problem at all. It looks like every other place in the plant. And equal opportunity, Morel's even gone to the aeroscalder. So we take the immersion part out of it. We use hot steam, if you will, kind of a new steam scalding system. Again, water savings, okay? And I'll try to move through this pretty quickly to get all my slides, because I never do good at this. How about chilling, right? We'll look at chilling. Chilling's the same sort of thing. Understand that often water conservation measures are part of food safety. We find them because we find that balance in food safety. I say that because that's really where this idea of air chilling comes from. Again, very, very little used, just kind of almost a niche market thing here still in the U.S., but a tremendous amount of water savings can be done there. And not go into great detail here on that because we don't have the time. But again, just to be equal opportunity, here's Bader. Almost all of our major line manufacturers are doing air chill systems now of different varieties. And it's not just a dry or wet. Keep this in mind. It's not just dry air chilling today or immersion chilling. There's a kind of a continuum there, all sort of moisture driving system, misting systems to try to get this idea across. Here's Morel, right? Here's mine. Everybody has their air chilling systems. And the highlight here that I want to say is the point being here is that there's often a trade-off between water and energy. What do I mean by that? So many times when we reduce water, as a great example is air chilling, right? From an engineering standpoint, there is nothing that pulls heat out of a carcass quicker than immersion chilling. We put them in air. Air's an insulator, by the way. That's what we use air for. And so what's the trade-off traditionally? Use less water, then I have to make up for it on the energy side, okay? Air chilling's a good example of that. The last piece I'll do here, and I'll flip through here right quick so I don't take too much of my time, is you notice I kept saying, we'll go back to the archaic 7 gallons per bird. No processor says they use 7 gallons per bird. None of them in the U.S. You talk to them, they may say 5, but a lot will say 4, 3. There's a reason for that. Because the reason is it may take you 7 gallons to process a bird, but almost every plant in the United States is reusing water in some way. And so the number that you get reported is how much fresh potable water am I bringing into the system. Not that total water use. How much is going through the meter to keep the system running? And the way we do that is through reuse. And let me just pop through these real quick so I don't take anybody else's time. Most of us understand what reuse is, and we have some options out there. And I'll talk about those very briefly. I do point back to the Northcutt and Jones's study. They actually talk about it in 2004, where at that time, 38% of respondents looked at reusing water. That's much higher now. I don't go into a plant where I don't see it. And it makes a lot of sense that the bigger the plant is, the more that they recycle. Traditionally, we don't do much of this. Most people think, well, no treatment. We don't really take water and do nothing with it and send it somewhere else. We're going to do something. Very traditionally, what is it? What do? We reuse it. Here's a great non-contact. We've been doing this for decades. We feather flume the water out of the production floor, right, the processing floor. We put it through primary screens. We take that water and recharge those flumes. But we even traditionally, homage to Scott Russell here back in 2010, red water rechilling. Even in contact situations, we can do it. Much more popular today is this idea of taking either single point to single point, or taking multiple points, taking water, if you will, from multiple points, treating it centrally and sending it back out to multiple points. This option that we do, open loop, or we would call it A and B. And I have examples in here, part of the Clean Water Awards. There's Watt Poultry again. Here you go, Terrence. Watt Poultry, reporting our Clean Water Awards for U.S. Poultry, talking, and this is Marshall Durbin, now Marjack in Jasper, Alabama. Here's a plant only doing about 1 million gallons a day. They're recycling 300,000 gallons of water a day. And just another quick example, right? where you see plants in the hundreds of thousands of gallons a day coming back into their facilities. Ultimately, if you have to, not very popular, but we do have what we call zero liquid discharge. The feeder for this idea that you ultimately would not have, you fully recycle all of your water. And most of us understand the issue with that. When we do get into this world, we start to deal, and you start to see these terms like, right, very familiar to us now, microfiltration, ultrafiltration. We get to learn now exist in the world of microns, right? Microns. And if you look at this traditionally, we're not talking about here's particle filtration, but if you start looking down here through micro, ultra, nano, and ultimately the Cadillac, reverse osmosis, not only do you see there's albumin protein, there's egg white. Can you believe we take out egg white with membranes? But not only that, look at food safety, bacteria, viruses, all through membranes. And just my last slide to bring it all full circle, if you look at this, from 1977, remember that new technology at DAF? Well, guess what? This last paper I'm showing you is them using ultrafiltration membranes to replace what? Dissolved air flotation. Thank you all very much.